In order to implement a four-stage model in vZoom, it is essential to understand the data flow model and process in vZoom. Data flow in vZoom is defined by using demand strata and demand segments. Among these, demand strata are related to trip generation, trip distribution, and mode split. Demand segments, on the other hand, are associated with trip assignment. Let's create a demand model with demand strata, demand segments, modes, and related matrices. First, create two modes of transportation for auto and bus. To do this, click the Demand menu, then click TSYS, Modes, DSEGs. Click the Transport Systems tab and click Create. Enter Auto for code and name. Since Auto is a part of private transportation, select PRT for type. Click OK. vZoom will ask if you wish to create demand segment and mode for the TSYS. Click OK. Now let us create another transport system for bus. In the Transport Systems tab, click Create and enter Bus for code and name. Select PUT for type. Click OK for creation of demand segments and modes. We must now create a walk TSYS and mode so that walk access to transit is possible. To do this, go to the TSYS tab and click Create, then enter Walk for code and name. Select Type as PUT Walk. Click OK. For Permit TSYS on Modes, click OK. This will allow the walk TSYS on other modes, thus making the mode walk possible. This completes our TSYS, modes, and DSEG definition. Click OK on the main menu. The next step is to create the required demand stratum for defining data flow in the model. To do this, click the Demand menu and select Demand Models. In the Basis tab, double-click the code and change the name from default to, say, A. Also change the name to A. Click on Person Groups and click Create. Rename the group from Group 1 to All in the code and name. This means that we just have a single person group in our demand model. In case of a cross-classified model, we may add more than one group based on the cross-classification level. For example, income group 1, 2, and 3 if we have persons classified based on income levels. Next, click on Activity Pairs and create a couple of activities, say HW and WH, representing home to work and work to home trips. When combined, these will represent home-based work trips. To create demand strata for these activity pairs, click the activity pair and click Create Demand Strata. This will lead to creation of demand strata related to the activity pairs automatically. To see the newly created demand strata, click the Demand Strata tab. Once a demand stratum has been defined, matrices for trip distribution and mode choice need to be created and linked with the demand strata and modes. To create matrices for distribution and mode choice, click on a demand stratum and click Create Demand Matrices. This step will also link the demand strata to the OD matrix that gets the result of the trip distribution, and also OD matrices where results of the mode split are stored. To view the mode choice matrix linkage, click a demand stratum and click Demand Matrices for Mode Choice. This displays a list of demand strata and associated matrices with the demand strata. The matrices associated with the demand strata may be changed by clicking the drop-down window and selecting the appropriate matrix from the list. Once all the matrices are associated with the required modes, the definition of demand model structure and OD matrices is complete. Trip generation is the first step in the four-step modeling procedure. The essential elements of trip generation in vZoom are 1. A demand strata, 2. Land use data stored in a zone attribute, and 3. A trip rate. To define a trip generation step in vZoom, go to Calculate, Procedures, click on Create. Here, select and expand the demand model tree, then select Trip Generation and click OK. Now click Selection D Strata and select one or more demand strata from the list of available D strata. Click OK. Once we have selected the required D strata for trip generation, we must define the equation for trip generation. This is done by clicking the Parameters button, which opens up a new dialog box for the definition of trip generation parameters. There are three checkboxes. The first one, linear combination of attributes for active zones only, allows the user to perform a trip generation calculation for only active zones in case a zone filter is active. The second checkbox, matrix balancing for active zones only, when checked on, performs a numerical balancing of trip generation vectors for only active zones. The third checkbox, sum up values, when checked on, will sum up a previously calculated trip generation to the current trip generation, thereby performing a cumulative trip generation. This is especially useful when special generators are being used in trip generation. After selecting the required options from the checkboxes, select the demand stratum for which the trip generation rates are to be entered from the drop-down menu. Next, select a method for balancing from the 5 available options in matrix balancing. If no balancing is to be performed, select None. The next step is to define the trip generation equation. This equation is simply a linear equation with variables and coefficients. The variables being zonal land use attributes and coefficients being trip rates associated with those land use attributes. To create an equation, click Insert Row, then click on the newly created tab that reads 1. This will allow you to select the zonal attribute or land use value being used for trip generation. These zonal attributes or land use values are usually stored as user-defined attributes. After selecting the required attribute, click OK. More attributes may be created by repeating the same procedure. In order to remove an attribute from the equation, select the attribute and click Delete Row. Once all the variables are added to the equation, the next step is to enter production and attraction rates. To enter a production rate, click the production rate column for the required attribute and enter a rate. To enter an attraction rate, click the attraction rate column for the required attribute and enter an attraction rate. Trip rates may be copied and pasted to and from a spreadsheet. The Apply to All Demand Strata button applies the same rates to all selected demand strata. Once the parameters and equations for trip generation have been defined, click OK and click Execute on the Procedures menu. The results of the trip generation may be viewed by going to Demand, then Demand Models. In Demand Models, to the Demand Strata tab, select a demand strata and click Productions and Attractions. The trip distribution step follows the trip generation step in 4-stage modeling. In this step, the production and attraction vectors, or P and A, are converted into trip matrices or OD tables. The basis for distribution of trips among zones is usually an impedance function. This is a measure of perceived impedance experienced by travelers going from one zone to another zone, and is usually a combination of a functional form applied to a shortest travel time and/or travel distance matrix, known as a skim matrix in VZoom. The necessary elements for a trip distribution implementation in VZoom are thus a demand strata for which the trip distribution has to be performed, one or more skim matrices, and a functional form with calibrated coefficients. Let's now create a trip distribution step in VZoom. Click Calculate, then Procedures. In the Operations tab, click Create. Double-click the Demand Model tab to expand the tree. Within these options, click Trip Distribution, then click OK. Now we must select the demand strata for which we need to perform a trip distribution. To do this, click Selection D Strata. From the available options, select one or more demand strata for which you wish to perform the trip distribution. To select a discontinuous demand strata, hold the Control key and click on the required demand strata. Once the required demand strata have been selected, click OK. Next, we define the parameters for the trip distribution. To do this, click Parameters. In the Demand Stratum dropdown, select a demand strata for which the trip distribution parameters are to be defined. The resulting demand matrix box will be automatically updated to reflect the matrix to which the calculation results will be sent. Recall that this connection was created while defining the demand strata for the model. In the Utility menu, click Create to insert a row. Then, click the Matrix Attribute Constant drop-down to select the skim matrix to be used in the impedance function. If an origin or destination zone attribute is to be included in the impedance function, it may be added to the matrix by creating another line in the utility term and then clicking the matrix pull-down and selecting Origin Zone ATTR or Destination Zone ATTR from the list. Once these are selected, a zone attribute to be included in the utility function may be inserted by clicking 1.0 and then selecting the zone attribute from the attribute list. One of the attributes typically used in the utility function is a parking cost attribute on the destination zone, or a CBD dummy. A transformation may be added to the utility term by clicking on the drop-down list box and selecting a suitable transformation. Once the required utility function has been defined, parameters for trip length frequency distribution must be defined. To do this, click Distribution Model, select a model functional form, and enter the corresponding model coefficients under the parameters A, B, and C as required. In the Options tab, clicking Production or Attraction for the direction of distribution will determine the direction of the outer loop of the matrix balancing procedure, whereas doubly constrained multi-procedure consists of the balancing targets for the inner loop of the matrix balancing procedure. Usually, the direction selected depends on the trip end data in which the modeler has more confidence. For example, if the HW strata trips are to be distributed, it makes sense to select the production as the direction of distribution because generally we have more reliable data on the home end of the survey. In order to examine a graph of the functional form, select the Functional Graph tab. This shows a curve representing the function with given coefficients. This curve may be modified by changing the coefficients in the parameters inputs boxes. Once a parameter value is modified, click Apply to see the modified function curve. To change the scale of the chart, limits for x and y values may be entered in the Range menu in Xmax and Ymax input boxes. Once the demand distribution parameters have been defined, click OK and then click Execute. This will run the trip distribution procedure. Once the procedure is run, you may look at the results of the trip distribution using the matrix editor. The mode choice procedure is used in order to determine the number of trips using a given mode of transportation. The mode choice is dependent on a utility function that comprises of variables such as travel time, travel cost, etc. vZoom allows the implementation of mode choice models with the nested mode choice procedure. As the name suggests, in a nested mode choice model, the mode choice is evaluated in a series of decision trees. The probability of each mode choice inside a nest is conditionally evaluated given that the nest has been chosen. Let's create a nested mode choice procedure in vZoom. Click Calculate, then Procedures. In the Operations tab, click Create. Expand the Demand Model tab and select Nested Mode Choice within it, and click OK. Click the demand strata for which the mode choice is to be calculated, and click OK. Next, click the Parameters button to define the nesting structure and utility function for the model. On the left side of the parameters definition, we will define the nesting structure or decision tree for the mode choice model. To do this, click Create Mode and select, say, the Auto mode. Now we need to create another nest for transit and subsequently add modes to this nest. To do this, click on Root and then click Create Nest. Type in a name for this nest, say Transit, and click OK. Now we must insert modes within this nest for transit modes. To do this, click on Transit and click Create Mode. From the options, select a mode, say Bus, and click OK. To add another mode to this nest, click on Transit again and click Create Mode. Select another mode from the drop-down options, say Rail. Using the same process, we may add more modes and nests in our model definition. To delete a mode, just select it and click the Delete button. Now that we have completed the definition of our nesting structure, we will associate the modes with output matrices for the nested modes. In general, if the demand matrices were already created when the demand model structure was being defined, the matrix linkages will be automatically created. If not, then first create the required matrices manually and then link the matrices with the modes. To do this, click on the required nest or mode, and in the resulting demand matrix menu, click Matrix Selection. From the list of matrices available, select the required matrix and click OK. Next, a utility function for the mode choice must be defined. To do this, select a mode from the decision tree. Then, in the utility window, click Create to create a utility term. Multiple lines may be added by repeatedly clicking Create so that all variables in the utility function may be accounted for. To specify coefficients for these variables, click on the Coefficients entry box and enter the required coefficients. To enter the log sum coefficient or nesting coefficient for a particular nest, click on the required nest level and enter the value of the coefficient in the log sum entry box. Once the utility equation has been defined, we select the mode choice model function associated with the utility equation. To select the mode choice model function, click the Mode Choice Model Function button and select the functional form of the mode choice model. Then click OK. If you wish to save the utility matrix as a separate matrix in order to analyze it, click Save Utility Matrix As and select the location of the matrix from the list of matrices in the drop-down menu. If there is a change of the nesting structure during the calibration process and it is required that modes be moved between nests, you may do so by clicking a mode, then clicking Shift, and then selecting the new parent node for the mode from the drop-down menu of available nodes. Once the mode choice model structure has been defined, click OK and hit Execute to run the model. The fourth step in the four-step modeling process is traffic assignment. In this step, a trip table obtained from the node split process is assigned to the network. This helps determine the number of vehicles using certain links and thus roads in the network. To define an assignment step in vZoom, click Calculate, then Procedures, then Create. In the Operations dialog, select Assignment and click OK. Now, click the Selection Deseg button and select the demand segments to be assigned and click OK. Public transit assignment may be selected by clicking Select Mode and selecting PUT. The details of the public transit assignment have been described in detail in another section of the tutorial that handles public transit modeling comprehensively. vZoom offers various assignment methods. To select a method for assignment, click the drop-down menu against the procedure and select the required assignment method. A detailed spreadsheet containing the description and use cases for all these assignment methods are provided with the documentation. The most common method for assignment is the equilibrium assignment. To define the parameters of the equilibrium assignment method, select Equilibrium Assignment from the drop-down menu and click Parameters. Enter the OD demand share per iteration step as required. Next, enter the assignment stopping criteria. Usually, it is best to have 0 absolute deviation, 0 relative deviation, 15 to 20 for number of iterations, and 0.00001 for relative gap. The stopping criteria for network balancing iterations may be entered by clicking Max Number of Iterations dialog. In order to reuse paths from a previous assignment, click the Use Current Assignment Result as initial solution if required, and click OK. Keep in mind, though, that the option of reusing paths is not available with the multipoint assignment method. The multipoint assignment method allows assignment of the trip matrix onto the network using multiple connectors with predefined weight or shares. Thus, access points to the network from zones can be more accurately modeled using the MPA assignment method. To turn on MPA, click Functions in the Procedures menu. Then, click the drop-down under Connector Weights Apply To. Here, select each single OD pair. Select the Total Trips MPA Off to turn MPA off. It is also possible to turn MPA on and off using the zone attributes in the procedure file. In order to do this, exit from the Procedures menu, select Zones, and right-click on the network to start a multi-edit. Select Use Origin Shares for PRT. Click Constant and select Yes. Click OK. Next, select Use Destination Shares for PRT. Click Constant and select Yes. Then click OK. Then click Close. Now, click Calculate Procedures and click Create in the Operations tab. Double-click Miscellaneous to expand this step, then select an Edit attribute and click OK. Click Parameters, select Zones as Network Object Type. In Target attribute, select Method for Connector Shares and click OK. With Constant checked, enter 1. Click OK and execute the step. This turns MPA on for each zone. Similarly, to turn MPA off, enter 2 instead of 1 in the constant text entry. The next step in setting up the assignment step is to define volume delay functions for links. Volume delay functions are used to evaluate volume-dependent travel times on links. vZoom has 3 types of volume delay functions: link-based, node-based, and turn-based. Let's define a link-based volume delay function. Click Calculate, then Procedures, and click the Functions tab. Double-click PRT functions, click Volume Delay Functions. To create a new volume delay function, click Create in the Volume Delay Functions menu. In the Volume Delay Functions Parameters menu, click the drop-down against Type and select the required volume delay function. Then, enter the appropriate parameters for the selected volume delay function and click OK. The next step is to associate this volume delay function with a link type. To do this, look at the row number in the matrix and the column number in the matrix and enter the volume delay function number in the matrix cells corresponding to the link type. For example, if you want to associate volume delay function number 2 with link type 1, select row 0 and column 1 and enter 2 in the corresponding cell of the matrix. This will associate link type 1 with volume delay function number 2. Now, let's create volume delay functions for nodes. Click Node Impedances, then click the drop-down menu for Method of Impedances at Node and select Nodes VDF. To create a new volume delay function, click Create and select the required volume delay function from the drop-down list and enter the coefficients. Then click OK. Now associate the volume delay function with a node based on the node type in a similar manner as done for links. For example, if the node type is 10, then pick the row corresponding to 1 and column corresponding to 0 and enter the volume delay function in the corresponding cell. To create a turns volume delay function, select turns VDF in the method for impedances at node. To create a volume delay function, click Create, select the required type of volume delay function, and enter the coefficients as appropriate. Then click OK. Now associate the newly created volume delay function with the turn type by entering the number of the volume delay function against the turn type in the turn types list. Notice that there is just one row in this table. This is because VZoom allows turns to be classified as type, ranging from 0 to 9. As for node and link types, these can range from type 0 to 99. If both turn volume delay function and node volume delay function are to be used as a combination, after defining the turns volume delay function, select nodes VDF in the method of impedances at node. This will apply both turn and node volume delay function at the intersection. This completes the definition of volume delay functions. Next, we learn how to implement the method of successive averages in VZoom. This method of successive averages involves performing a weighted averaging on matrices from the current and previous iteration, giving higher weight to the matrix calculated in the previous iteration. To better understand the MSA process, we take a look at the procedure flow. Let's implement this process flow in VZoom. First, create an extra matrix, skim matrix or OD matrix, as a placeholder to store the previous iteration matrix. Do this by clicking Demand, then Matrices, and clicking Create. After this, allocate a type to this matrix, skim or OD demand, by clicking the Matrix Type drop-down. Then click OK. Now go to Calculate, then Procedures, and click Create. Then double-click Matrices and select Method of Successive Averages over Matrices. This step should be moved to a location after the trip distribution step. To move this step, click the Procedure step and then click the up or down arrows to bring this step to the right location. Then, click Selection Matrix and select the matrix that will be updated, in this case, Matrix 16. Remember, you may decide, based on your case, to perform the MSA procedure on a skim matrix or an OD matrix, but whatever the case may be, keep in mind that you must compare matrices of similar type. That is, an OD matrix with an OD matrix and a skim with a skim. Now click Parameters. For matrix 1, select the matrix calculated in the previous iteration. Then, for matrix 2, select the most recently calculated matrix. This matrix will be the matrix that results from the trip distribution. As you can see, there are two weighting options for the matrices. We essentially want to give higher weight to the matrix from the previous iteration and lower weight to the matrix from the most recent iteration. Click OK. This completes the definition of the method of successive averages. The next step is to define a conditional go-to procedure so that a feedback loop can be implemented. To do this, create another procedure by clicking Create in the Procedures menu. Double-click Miscellaneous and select the Go-to Operation option within this menu and click OK. Click Parameters and enter the step number for the skim matrix calculation step. Then click Matrix. From the drop-down menu, select the matrix that is being used for assignment. In the deviation values, enter 0.01 for both min and max values. This is the convergence criteria. Accordingly, if a matrix cell value is different by 0.01 from the previous iteration, the loop will restart. If this condition is met, then the loop is stopped. Lastly, enter the maximum number of iterations before stopping the looping. This means that if the deviation criteria of 0.01 is not met, a maximum of x iterations will be performed, x being the number you enter in the number of iterations entry box. This completes the MSA procedure for four-stage modeling.